active speaker system ISPO1200AS2 and 200AS2. End-to-end tutorial how to build active speaker system for three-way speakers. For experiments I need an amplifier solution to drive three-way active stereo system and decided to build it as my next weekend project. First I set requirements for my system. It's always wise to write those down before designing something. You can change some bits and pieces based on availability and budget later, but such a structural approach will save a lot of time later. So, I want the best sound, of course, preferring certified and proven manufacturers as long as it fits into the budget. The system should have balanced inputs because it will be using a professional analog crossover. I will use my stock crossover Behringer CX3400 Super X Pro. Our recommended woofer power 300 watts. Mid-range 100 watts. I'll be driving 40 watt RMS mid-range and 100 watts are exactly what I want. Tweeter 100 watts. I have SB Acoustics SB29 RDNC C0004 ring dome tweeter with 100 watts RMS capability and high sensitivity of 94 decibels. In reality, I need a couple of watts to drive it. And I want that my project fits in 250mm 2U rack mount enclosure. First I did a quick search about enclosures. Maybe I can find some ready-made and adapt. I have one specific requirement. They should be placed for 80mm fan at the rear side of the enclosure, and the enclosure material should be aluminium, so I can easily mill necessary cutouts. I put in a search 2U aluminum enclosures, get plenty of possible options, and not all of them fits, but let's take for this one. It looks nice and well designed. So, costs are acceptable. Geez, shipping by DHL, 100 euros. But anyway, for a sample, it's kind of okay. Yeah, it's modular. It's easy to assemble. Right dimensions. What else we can see? It's aluminum alloy, 663. It's very easy to mill. There's two types of materials, but both are great for milling. What else? UPS, DHL, China Post, delivery terms. Anyway, it's expensive. Supply capability, huge, somewhere. It's exactly what I need, 250 millimeters. Okay, it's rack mount, so standardized, but depth is 250. That looks good. And here's the problem. I need these 80mm fans, and they doesn't fit US 78mm. I was looking to this design for a long time, and someone who decided about the shape of this element or I don't know how it is made, but it definitely is not able to accommodate that 80mm fan. No way. I checked many others, but if I can't take this one, then seems it is better to do it by myself. So I decided to build that rack mount chassis by myself. Here is my design. It consists of 8 pieces. It's front, 2 sides, back, top, and bottom, and 2 brackets. Brackets meant for assembling in a rack. Some specifics what I made. First, there are large cutouts to minimize airflow noise. I want them silent. And there are 2 switches, one for a low frequency board and second for stereo mid-range. There are cutouts for standoffs. You can put on the side components also some electronic boards. What we have in the back, we have wake up from signal switch, and we have 12 volt also trigger options if you want. Of course, there is a mains, there is a two cutouts for 8mm fan. There are connectors for a speaker, those are speaker connectors, and XLRs for a main input. That's it. So simple, lightweight, 1mm aluminium case. Let's build it. Let's build it now. So I programmed CNC machine, doing all job instead of me. There is much higher precision than doing it by hand. You can see in accelerated way. But anyway, I started with the top and bottom components, and machine quickly finishes it. I'm already rather experienced in that. I built a number of enclosures, so there's no problem of it. You can see everything went fine. The second, I'm building front and back. Also, it went smooth. You need a lubricant to get the best possible quality. My pad is wearing up, so I'm using sometimes some additional stick to just prevent pieces from going away from that. Vacuum is not working well anymore if your rubber pad is wearing out. So, but everything went smooth, and components are well designed. No any dimension problems. Everything is exact and accurate. So afterwards, we press some rivets, or we press some metal threads. Aluminium is not strong enough to make a thread in it, and this pressing allows you make a rigid construction based on that specific methodology. Also, with the simple instruments, you can do a lot of stuff, and this is a good example of that. You always need to build a prototype. Even you do in a CAD software, no great job. There are tiny things what you need to see in a three-dimensional in a practice, or you maybe haven't thought about it. Of course, if you do the CAD really in a way that each components are in it, but for prototypes it takes a lot of time. You should develop in CAD program any its tiniest components and put together and look at it. But normally, if I have more time, I would do it in a way that all components would be developed in a CAD. For a paid designs, I'm always doing a full detailed CAD components development. So next is folding operations. You use kind of template for that. It's important. Even you measure precisely, you can't always repeat it. So those templates make it like a technological process when you have repeatable tolerance. Now we developed several designs and then try to keep it standardized, at least at prototyping moment. You can see that everything is folded perfectly, even 4 pieces. Then we do it the same for a back, and later for a front. So always use a template, and then you have repeatable tolerance for everything. So great. How does it look when you assemble it? Actually, it's perfect match. You can see all components fit together well. Brackets are here. Backside cutouts are precise, and it matches very well. So this is a modern design. When you design in a CAD and do the CNC machining, it's fine. Choosing the board. Let's take a short look into Sounding Pod shop and what we have from ice-powered stock. Here is listed second generation top boards from ice-power. Like 1200AS2, you can get one time, you can get 60 watts per channel on 8 ohms. then 200AS2, 120 watts on 8 ohms. Probably this is one of the candidates. Then we have 300AS1 with a module, and you can get 150 watts on 8 ohms. And with the hanger modules, you can build another great solution. Then there is 700AS2, and this is interesting board because you can have a hanger module and with a 40 volts, and you can make kind of combination between ice power board and some China manufactured boards. We will look briefly on them. And then, of course, my favorite, here is 1200AS2. It's a perfect amplifier if you use it as just an amplifier, and then you can combine it with 200AS2. You are separating power supply because it has separate power supply from this one. You can run woofer as a hell and not impact the mid-range. Several combinations what we can make. And here is one what is dedicated and built as a three-way speaker system, but you can see that for the woofer you need a 4 ohm woofer. You are locked to the 4 ohm woofer. If you have 8 ohm woofer, then it's not that good solution. But otherwise 300 watts for 4 ohm woofer and 150 watts for a tweeter, and mid-range is almost perfect. This is almost perfect if you have 8 ohm woofer. Or if you are going to build something, then you can choose 4 ohm woofer and 8 ohm mid-range and tweeter. This limitation is determined by rail voltage what has this board. And that means you have the same rail voltage for all boards, and definitely you have 300 watts for 4 ohm and a mid-range in that case, and that could be dangerous. I would say that it's 150. It's absolutely perfect for any mid-range you can use in home applications. Even you want to run it loud as a hell, it's a perfect one. One more thing to think about, and I have concerns at beginning on this video. You can see this ice power 200 board has relatively high output impedance or low damping factor. It's about 20, and I'm thinking, will it be able to control my mid-range speaker? And only experiment can answer of it. There's those boards that side by side. Ice power 125 has 200 damping factor, about 200. It's 20 milliohms output impedance, and ice power 200AS2, it's 180 milliohms output impedance. It's about 20 on 4 ohms and 40 on 8 ohms. 40 on 8 ohms actually is great, but 20 on 4 ohms are just good. Let's make experiment and listen, and then we can answer to that Sakra question. Okay, we are in Sound Import Shop, and let's choose the boards. The first option, ice power 300AS1. It's nice board, and we need a hanger module. You need 2 for your setup. Okay, let's round it. 90 euros per board. You need 2 boards, 180. And then we can go here. It's 160, 350. So for one channel, 350 euros per channel. You need two per stereo. You need 2 channels. It's 700 project. What else we have? We can build the same board with ice power 200AS2. In that case, you will separate woofer power supply from mid-range and tweeter for power supply. You need 2 boards for that. So this is 160, 320. For one channel system, you need 1 board 160 and one ice power 200 board. It's 320. For stereo of 640, you are at 640 budget. to build. But you will get a separated power supplies for woofer and tweeter, and that's good in case when you need to run woofer system at a clipping level. Your mid-range and tweeter will be perfectly fine, and our sensitivity to low frequencies, total harmonic distortions, are significantly less than for mid-range. We are very sensitive. What else we can do? We can take iSpower 1200AS2 in a stereo, and we get about 600 clipping power for a woofer, and about 400 clean power, that is absolutely perfect. In that case, combining with iSpower 200AS2, we need 2 boards for a stereo system. The total will be 430 plus 2 boards, 320, 750. 750 will be our project with a top of the top board for a woofer. We also can use it in stereo in some scenarios if we need. And 2 boards iSpower 200AS2. There is another one. We can use iSpower 125AX2 in a bridged connection, and second board in a single-ended connection, and get for 1 channel 3-way active speaker system. But for some reason, iSpower is not pushing this board in the market anymore, and it costs it's crazy high. You have 800 costs, and there are better solutions today than this one. Another interesting solution, iSpower 700AS2. Board is cheaper than 1200, but this board has one significant specific. And let's look at the specifications in the manual. What we can see, there is an option for hanger module, and voltage is 43 volts. This is only board what you can combine with some China boards. For example, with 2 of them, here's some kind of latest generation Chinese developed TPA 3255 boards, and by using 2 of them, it's 27 per board. It's nice price. They're shipping 11. If you no, it's more. So it's 39 per board, 2 boards, estimated budget 80 euros. Or you can buy such a board where both channels is in the same on the same board. They have balanced inputs for 51 and shipping 6.86. Great price. So about 60 euros you can get your setup. That means if you combine this board 380 plus 60, you will get 440 for full stereo setup. Of course, I didn't tested them, but there is a lot of reviews in YouTube, in many other sources. In general, those boards sounds good, and majority of those boards are manufacturer reference design clones, and there's little risk about it. The key issue of those boards is that heatsink is too small for full power. They are static at 300 plus 300. You will toast it immediately. If you don't put active cooling for them, it's the same for this board. There is even 2 boards on it. But when you are running it in active speaker systems, then typical consumption of mid-range and tweeter is about, maybe 20 watts, maybe 20. You have a lot of headroom, and it's perfect. It's less than 20. Typically, at the loudness what you are listening, and 99% of your time, it's about it's about 10 watts. Yeah, you should get it out. You have a lot of headroom. It will sound amazing. Should sound amazing. Also, what risks you have? There's a lot of rumors. Is those chipsets original Texas Instruments chipsets, or those are fakes, and some prices are so low? I don't think it's a clone. There is kind of chipsets what doesn't meet manufacturer tests, and those are sold for nothing, and then they use it in projects. So far, majority of feedbacks from the market is okay, but I didn't test it, and I have no responsibility about what I'm saying now. So it's just a thinking loud what kind of solution you can make about it. What is my choice? My choice is 1200 and icepower 200AS2. I need 2 boards for that, 1 board for that, and let's build it. So, assembled chassis, and first thing what I want to know, what is a chassis weight, because it's directly related to shipping costs. And I found out it's about 1 kilogram. And then what will be weight if I put all boards in. I'm doing some rough estimation, and it gives me about 3.5 kilograms. Anyway, shipping costs will be higher. I do some verification of dimensions, and the depth is 250 millimeters, height is 88 millimeters. It matches to your standards, and I'm happy with that. Now we should assemble everything together. And first thing is assembling boards. What I do at the first phase, I need to measure all wire lengths. I would think about best and optimal configuration, how to place the wires, how to split them between the layers. I want to separate high power from the low power. That eliminates potential crosstalks and I know some unnecessary potential feedbacks and many other things. So it's better to separate low signal layer from high signal layer and from the mains. You can see assembling is very easy because I did it on a CNC machine with properly measured in a CAD system, properly designed holes. They perfectly matches, even more than perfectly they matches. This bottom plate will work also as an extra heatsink. Now we choose the components. You can see my treasure box. It's a great treasure box. You can see that for prototype it's quickly dries out my components because you need plenty of them. You need 6 XLRs, you need 6 Speakon connectors, you need mains, and you need a main switch. You can see how quickly components dries out. Some compartments are empty, but that's fine. So now you should secure all of them. I'm showing it in accelerate way, but anyway, it doesn't take too much time. One of the advantages of my design when I have 6 separate components for 2U rack enclosure is that I can assemble them separately. It's very easy to assemble. And here I want to show why you need a prototype. There is a mistake, and this mistake is not done by CNC machine. I took wrong dimensions of input connector, and I need adjustments. So that means I need to fix my initial CAD drawing and verify dimensions of component and cutout. For this specific prototype, I was out of fan grill, so I'm assembling without a fan grill. For prototype it's not problem, but for normal operation it's better to have it. Now I'm doing the wire length draft, so I'm thinking about the paths, how they will go. It's also about the layers, and then I do the rough estimation. I'm making them longer, and the science here is to make them longer than you need. And then you process one side and decide about another side. When you put everything together, you will have a prototype with right wire lengths, and afterwards you disassemble and make a documentation how long those wires could be. Could you do it at a CAD level? In reality, you can't. It's too much work. It's much easier to do that one. And even though you make it in a CAD, afterwards you need to verify in a prototype, and those lengths will change. So I think this is the best way how to do it. It doesn't take too much time, but important thing here is that you make all those wires in a proper length. So this is 8 hours later. Yeah, I spent 8 hours crimping all the wires, finding the best possible configuration of those wires. Overall, I'm happy with the result. Maybe they don't look so tidy, but they are done properly from electromagnetic compatibility things. You see, this one wire is kind of challenge for me, that it is 220 volts for a board. There were several ways how to place it, but I find out this is the best one. It doesn't look too aesthetic, but from practical point of view, it's nice. So this is a assembled unit, and now we are ready to test it. Also, it works. Yeah, I don't have grills, but otherwise it's fine. It's fine. A lot of screws, a lot of manpower, but nice and light. For my project, I decided to put everything in a flight case. It is kind of easiest way how to assemble and make it look like one unit. Also, it is easy to move around and take for other experiments or for other places. I have several locations where I'm doing my experiments and I'm doing my prototyping, so I can always take it with me, and it's a good solution. Someone who like fancy enclosures maybe will not be happy with that, but from practical point of view, those rack mount designs are very good, and you can buy for fraction of price volume products. So assembling is going smooth, everything fits in it. I have a short XLR patch cables that I'm using for that. And then taking my small test speakers. Those are very cheap speakers, even I burn it, it's no problem, but it's absolutely safe because they have internal filter, and it protects speaker if I put a low frequencies. Otherwise, if I put a low frequencies for the tweeter, I will not hear it, and then I add some volume and I burn it, because a tweeter is really fragile for that. Here you can see that low frequencies are correct. This is low frequencies, mid frequencies, and here are high frequencies for three-way speaker system. We do it for second channel, the same low frequencies, mid frequencies, looks fine. And then we test tweeter, and you will find out how much responsibilities tweeter has in our audio reproduction. And now I'm connecting to my main speakers, those active speakers. It is safe. I have marked connectors with this blue sticky tape. Yeah, it's pretty loud. I should take away some volume. It already sounds great. And now you are connected to the main speaker, and next you should do the crossover sonic balance between the loudspeakers. If you have good ears, you can do it without measurement instruments. Just take good headphones, connect to your audio interface, and do a listening test. You can achieve a relatively good result with this simple method. Of course, the best way is to do it with measurement microphone, but then you need more skills. There was a fraction of a music fragment where you can hear how round and nice is a bass. I hope YouTube will not ban it. And now I'm comparing fan noise. You can hear only environmental noise. Only noisy device is my computer here. So I also did tests with a passive crossover to find out is active solution worth it. This is a good passive crossover with a air core inductors and relatively expensive. And what is the result? Result is day and night. Once you put a crossover, all magic of tiny details disappears. It's still sonically balanced, it still sounds good, but there is also tiny bit of difference about clarity and energy of speakers. You are controlling much better it with an active solution. So, next step, of course, is active solution. Here I'm thinking what would be the best orientation of boards, and you can see the best orientation of boards it would if they would face a back plate, but unfortunately it's not possible in a small size. Otherwise you need full size rack mount 2U unit. And there is no difference in audibility, only your wires are longer, but this is the smallest footprint that you can achieve. In general, I'm happy with the result. It's easy to assemble. If you know the wire lengths in advance, you can prepare cables and do also a kit, but I will not make kit because I don't see a business. How can you use it? You can use it as a good stereo amplifier. You can use it as a super good home cinema system where fronts would go for the size power 1200, and also fronts you can use for music listening, and you can do three-way active system based on it. So there are applications, but for crazy guys only who want to build something, listen something, experiment. What was listening experience a big surprise for me? The big surprise for me was that for a mid-range 1200AS2 sounded tiny bit better than 125AX2. And the question is why? First conclusion what comes that for mid-range speaker, or for that particular speaker what I had, damping factor is not critical. Okay, my mid-range working from somewhere from 350 hertz up to 3.5 kilohertz. It's still in range when you have pretty good control. But what is the difference between 125 and ice power 1200AS2? The key difference is that for mid-range it's running in single-ended connection, and this is running in a bridged connection. Let's take a look on schematics. Here is manufacturer schematics for the TPA3255, and this chipset I think this chipset is used in 200AS2 board. Stereo BTL application. This is how ice power 200AS2 has been set, and this is BTL. And since it's set in a bridged connection, it has high sleeve rate. It is limited by bandwidth of this output filter, and normally it's about 10 volts per microsecond. But if you put in a bridged, then those are 20 volts per microsecond. And I think this is a reason why those mid-range sound tiny bit better for ice power 200AS2. Of course, it's a guess. We should do some experiments. How this sounds better, I could describe. When you put piano music and some professional musician touches Steinway case, they have more energy. They are kind of perfectly blast. Yeah, it's perfect blast. And I think it's due to this bridged connection when you have a higher sleeve rate. Due to the filter, Class D amplifiers are a little bit impacted by sleeve rate on the higher frequencies. And here, in a mid-range, I think it plays the main role, the bridged. And I also can confirm that when you put iSpower 125AX2 in a bridged connection, it sounds perfect. And for perfect sound, you need at least 20 volts per microsecond sleeve rate. And here I also want expert opinion. How about the mid-range? How important damping factor is for mid-range? And I think it's not important. And let's go back to our PowerPoint. Okay, and here is our woofer. Woofer has high motor force, really high, and relatively high moving mass. In our case, I have very good speaker, and it has very good woofer, Satori woofer, and it has half of typical woofer mass, about 44 grams, but it's very good, good feature. And in that case, damping factor impacts that mass movement. It stops it like a brakes, forward, backward. It's very precise to respond. And then you need a high damping factor. But when we look at a tweeter, it's very good tweeter. It's crossed at 3.5 kilohertz, and you have it's a perfect linearity. It has a low force factor or low motor force and very low moving mass, 100 times less, and all parameters are defined by suspension system. In that case, damping factor is neglectful, because often in a passive crossovers we are putting resistive divider just to match the sensitivities. This is my theory. I have no proof. This is just thinking loud. And if you look at the mid-range, in my system, I'm using SB Acoustics dedicated mid-range with a shorter voice coil. You can see that force factor is medium, but moving mass is much higher than for tweeter, but also at least 10 times lower than for woofer. And that means largely the quality is impacted by or defined by suspension system, not by damping factor. That means we can use that iSpower 1200AS2 board for a mid-range and get perfect results. Because set in a bridged, it was really responsive, so clean was those piano placements. If you want to estimate it as ratings, then 200AS2 is doing at 10 points, and then iSpower 125AS2 it's doing at 9 points. We're talking about a tiny bit of difference. In both cases, it's perfect, in my opinion. But this experiment showed that somehow this mid-range becomes so energized, so precise, that I need explanation. And still, maybe there is some expert who can tell a little bit more. But I find out that damping factor is not making large impact on a mid-range. It's making large impact only on a woofer. I need a proof. If there are some experts listening my video, I would be glad to get the feedback. Why that experiment shown out very unexpected results, I would say. What I have learned from this project. It's a great project, building my speaker test system. In general, it went smooth and without technical challenges. I have built solution what has the following application areas. 3-way speaker driver system, my main goal. It's also excellent home cinema and music listening system. Portable and mobile system, lightweight, easy to transport. The total weight about 5 kilograms. Capable to drive any size home user speakers. Even the largest possible what you have in home, it will drive with a confidence. It could be part of expensive old speaker modernization project, so you are not dependent anymore on a built-in crossover. You can change mid-range and tweeter for modern speakers, and leave woofer what is connected with your enclosure volume as it is. In many cases woofer is okay, but mid-range in the past was kind of crappy. You can modernize your speakers and get incredible sound out of it. If you have cheap speaker system and you get rid of cheap crossover and start to drive your existing cost-effective drivers directly, your sound system will improve dramatically. It become close to high-end system. Will I make a kit? No. But if you want to build a similar solution, you can use the components. I have two kits, TCR 1200 for icepower 1200AS2 board, and second kit TCR 200 for this icepower 200AS2 boards. With three components, you can build exactly the same solution, and then you can combine it with active crossover and make it. If you don't need a mobile solution, it's very easy, and it will take less space than I don't know, some fancy hi-fi oriented or high-end oriented equipment. Would I get better result with DSP crossover? For three-way system, I doubt, because I'm using a modern loudspeakers, and those are extremely linear. Your room influence is much higher than influence due to the simple crossover, and the price difference is significant. And anyway, if you want a DSP crossover, you should be able to do speaker measurements at relatively high experience level. It's not just all peaks should be somehow dumped. There is science how to do it, and you should educate yourself. If it's your first project, don't go for DSP crossover. You will make crap out of your project. So, great project, and I'm recommending for everyone who wants to build incredible system. It sounds amazing. It really sounds amazing. I don't have room, and I don't have such a good microphones to do the recording for tests, but I was impressed. I was really impressed how it sounds.